Wanted to show a new tool I got that others might be interested in. This is the A.T.S. ESCAN Elite. It's by Automotive Test Solutions. It's let me shut it off. It actually speaks out some of your fuel trims, or if you have a charging problem.
Fuel trim. Correction, good.
Fuel correction, you can hear it right there. I'm going to shut the voice off for this video here.
Bank 1 to bank 2, fuel trim. Correction, good.
Should stop in a minute. So, that's one of the nice things. You can drive and it'll, it'll speak if you have a DTC. You can actually pair it to, I got turned on to the company because of their oscilloscopes. So, first thing you can do is look in the DTCs, and you can have your scope running on the same computer, and when it throws a DTC, it'll actually stop your scope. That's really useful, so you don't have to search through all the data. You can see what led up to the DTC. That's a really nice feature. And the tool's packed with really smart features. The president and partner of A.T.S. Are geniuses. He puts videos up, Automotive Test Solutions, and he shows how important a scope is to find the problems. You get guys that say, I don't need a scope, to troubleshoot. Yeah, you can work on a vehicle. I've worked a long time on stuff without a scope, but there are problems nowadays that you will not find easily without a scope. At some point you will be guessing, I guarantee you. But anyways, this is not a scope video. This is a scan tool video. The other thing I should make clear is this is not a bi-directional scan tool. They've used just simple generic OBD and mode 6 data to make it's more of like a test tool. So I don't really like calling it a scan tool. It's more of just a test tool. Yes, you can erase codes, but you can't, bleed ABS. You can't relearn cam crank. You can't, do power balance. So don't get this scope thinking that's all you need if you're in the business. But anyways, what the genius of this scope is number one is this sharpshooter over here. Hold on. And what the sharpshooter is, it's a bunch of tests that need to be performed, and doing the calculations in your head would be tough. So, we can know what the fuel trim is at any moment by reading the fuel trims, but it's nice to map the fuel trim. So if you map the fuel trim, and you can do short-term, long-term, and an average, you can build cell data based on showing your fuel trim based on RPM and throttle position. So you can see, bank to bank, what's happening. That's really useful. You can tell where your problem lies, and in what condition the problems are, right? So fuel trim maps, really nice. Another one, volumetric efficiency, especially on older cars, and that's where we're getting a lot of the drivability problems as cars get older. You have to have a MAF sensor for this, and actually for a few of the tests in here. They scale the engine. A lot of the engines are scaled, so it's looking at a theoretical calculated airflow, and it's going to build a plot as you accelerate. It's going to, put a data point, based on throttle position, and how much air that engine should be flowing. It needs to meter the air. It needs to know the airflow to meter the fuel. So if you get like a triangle, or a plot that goes all the way up, and the actual plot does not go along with that, let's just say it's a lot lower than that, it'll display the difference. So basically you're not flowing the air that this engine should flow. Remember, an engine is just an air pump, so it's not flowing the air. So how's it going to meter the fuel and make the power that you need to make? So I could show, can't do the test on this car. I'm dealing with some oxygen sensor problems here on this car. So let's go mass airflow. Let's see if I can get my fingers are, let's see, we'll go VE chart. So right there, you can see what the VE chart would be. So that that car on that pole did not, make the air, pump the air that it should. And they build a load cell here, or a cell map, and it's showing the differences. So again, knowing where your airflow problem is, higher RPM, lower RPM, high throttle position percentage, that all helps. And there's a lot of information packed into the scope to help you. And then you can compare the data over here. So you can compare the fuel trim and the volumetric efficiency. And again, it's going to help you calculate where the problem is. It's looking at the difference based on the fuel trim. So it has an accelerometer in here. So you can do a poll and look at the horsepower. And, it's not like those junk apps. It's looking at, it wants to know barometric pressure, where you are. It wants to know the type of fuel, the weight of the gasoline, and there's an acceleration and deceleration map over here. So that's kind of neat. The diagnostic connector has an accelerometer built in. If you look at time to temperature, this is really nice. If you have like a thermostat problem, it'll build a cell map over here based on how many degrees per second you are rising or lowering, and it's gonna throw charts for vehicle speed. I think there's the temperature, time, and speed. And basically, if your engine's taking a long time to warm up, or warming up too quick, there's a certain amount where your engine's warming up too quick, or not warming up quick enough. So so you can troubleshoot thermostat problems there and stuff. Fuel efficiency, it'll have a fuel efficiency calculator. Here's one here. Is compression. It's called a relative compression test. I'll try to do it without doing it. So if I get communication here, let me put the car on. And I go. Let me get the data back. It's got okay, we're reading loop data, so I go into sharpshooter. I hit start test. Okay, you got to put the car in clear flood, and clear flood is just by holding down the throttle, and I'm going to crank it. It won't start when you hold down the throttle. Okay, there's the map. Okay, what that just did there, the diagnostic connector has battery voltage on pin 16, and what it does is every time, let me save this. I'm just going to put 300 for Chrysler 300. So you do this test with a scope, and they kind of built it in since they have a voltage reading right on the connector. This is basically a scope here, and it peak detects every peak. So you can see right there, each of those peaks is a cylinder at top dead center. So as you crank, or actually each valley is a cylinder at top dead center. So as you get to the top dead center of a cylinder, if it has compression, it's going to cause a little voltage drop. It's harder for that starter to crank over the engine. It's called a relative compression test because we don't know what the compression is, but if you had one cylinder or two cylinders or a bank, let's say it's a dual overhead cam, where you lost compression in one or multiple cylinders, well, obviously it wouldn't be hard for the engine to crank over. So you wouldn't get a drop in voltage at that cylinder. So you would see, let's say, like the third cylinder out, like, cylinder 2 is out. So on a V8, every 8 cylinders, every 8 peaks here, you're gonna have a no drop. The voltage will just stay level. Now, that if you wanted to know what cylinder it was, you'd pull out your scope, you'd put a sync channel in, and then you could tell, you'd say you throw it on cylinder 2, your ignition sync. You would be able to tell what cylinder it is by the firing order, how many peaks away from, you count with your firing order, how many peaks away from your sync cylinder the problem occurs. Now, we also don't know if you had every cylinder just had low compression to begin with and they all looked the same, it wouldn't tell you anything. Although you would expect there's a certain amount of voltage drop on a good battery that should happen. But this is to identify an anomaly. So in other words, if they're all low, they're all going to look the same. So you're hoping, usually you don't lose compression in every cylinder. It can happen if you jump timing, but it's just a base test to kind of point you in another direction. It's a quick, easy test, and it's very useful. So, and then it'll say, it'll show in percentage, if you have a low cylinder. So it's just one of those, it's very easy with a scope to do also. And then I've experimented, I've pulled out a plug and cranked it, and you can actually just see, bam, right there, it stays high, So anyways, that's a cool test. It's a quick test, and you're plugging in the connector anyway, so why not do it anyways when it may point you in a direction. Here's a good one, catalyst efficiency. So you can see the theme of what they're doing here. They're using basic data that would normally be on a lower end non-bidirectional scanner, and they're using that data to perform good tests, because the basic scanner has all the good information in it. Everything else in a high-end scanner, the bidirectional is the really only other reason you buy a higher end scanner. Everything else is just bells and whistles. This is really a tool to get in deep and diagnose with the raw data the drivability problems. So I'm going to stop that. I think I did stop that. So if we go in to, I was in catalyst efficiency, prepare for test. Now it's telling me that I guess I got some DTCs pending. That's the other thing I'll show you on this. So DTCs pending, if you go into mode 6, a lot of scan tools do not show what the actual mode 6 data is. You get a hex value and you don't even know what that hex value correlates to. You have to look it up. This is going to read all the mode 6 data. You can actually put in what vehicle it's on, and you can read it continuously. And I don't know, everyone's had a car and you got to go get an inspection, and someone's erased the code for you, and then you get there and they say they can't inspect it because you got to drive your car, for 50 miles or whatever, because you got to run all the monitors again. So this looks at all the monitors and tells you if you're close to tripping that monitor, it's satisfying the condition, to setting the code. Very useful. Let's say you're buying a car and you're right on the edge of setting, an oxygen sensor code or an EGR code. Very useful. You can see how close you are to tripping that code. If you own a shop and you fix a car for and you send it out, you don't want to get blamed for, as they driving down the road, something trips, some code sets, they're going to blame it on you. Well, if you run a report when you pull it into your shop and you see it's, very close to setting that code, you can tell the customer, hey, you have the record here, that, you can explain to them you're very close to setting this code. You can take care of the problem before they bring the problem back and blame it on you. So that's very useful. So that's what when I went to go do this test here, the O2 sensor test here, or the catalyst efficiency test, I also use it just to look at O2s, because it loads it right in these two maps here, these two graphs. You can already see the problem. So this is bank 1. Now, the scales are going to be different. So in this car, both are just regular old O2 sensors. That'll oscillate 0 to 1 volt, 1 volt being rich, 0 being lean, middle, like 0.5 volts, 500 millivolts. That's stoichiometric, which is like, a clean burn. And this one right here, the Bank 1 yellow, is the pre-cat, before the cat, and the red is post-cat, after the cat. This green, pre-cat, the blue, you don't even see, is after the cat. So a good cat will dampen that signal. The oxygen sensor, the second, the rear O2. But what you can see right here is, number one, you want oscillations on your O2, on your pre-cat O2. The engine is actually driving rich lean on purpose. The reason it does that is certain hydrocarbons and CO, they all, to burn them out using your cat, they all got there's a spectrum. Some of the emissions need to be in a lean condition to clean them up, let's say, and sometimes the engine needs to be in a rich condition. So to have a clean burning car, the engine needs to go rich lean, okay? So the O2 sensor the ECM is actually driving the engine rich lean. It actually, the ECM looks for that cross, how many times it crosses over within a period. If it just stays rich, or even, it could stay right on stoichiometric, which is a clean burn, and that would be bad. That would not be a good, it would be a clean burning car, but it'd be a clean burn, but you wouldn't satisfy the emissions. You wouldn't lower the emissions of the car. There's, like I said, certain hydrocarbons and CO, they all need to be burned out under a different state. I guess that's the easiest way of putting it. So you can see this rear O2. Now it comes up, and this doesn't scale, so it came up to 500 millivolts, but it shoots right back down. This is that O2. I either could have a leak in the exhaust where we're sucking more air and it's just reading lean. I have to look into it. Could just be a bad O2 also. So there's that. The cool thing is, if I go over to my PIDs, let's see, you can select which ones you want, so you can get a better, a faster update rate. So the more you read, and this happens on any scan tool, the more you pull, the slower the data points in between are going to be. So I can clear them all and only read one. If I enable the info PIDs, it enables the ones over here. Here's the monitor. So if you run the monitors, if I hit monitor right here, it'll read the monitors, and actually you can see, I think it's reading slow. It hasn't read all the monitors. It's reading them, and it's stopped. So the time to satisfy the monitor, and then it'll tell you how many codes and how many monitors did not run. So if we go to DTCs, and that's that heated oxygen sensor, it'll give you freeze frame data. So when that occurred, I think it will. Yep. Here's your freeze frame data. I think what else? Another thing that's very useful is, so I can come over here, I can look at a stacked graph, and I can place whatever I want in there. Now, like my Snap-on Verus and stuff, I can look at graphs. So that's, nothing extra, but I actually like the way the graphs are laid out here. But this is actually easier to look at graphs. The Snap-on, you gotta, you select what you want to read, and I can put these in whatever order I want. Where if I select a bunch, it's going to order it on just where they occur in the list. Not a bad thing. I love my Snap-on Verus too. So right now, you can see a graph here. But the other thing I can do, I can pull in some data. So I can get what's on dual A and look at that data. I can shut off the red. So the red's scaling high, so I can get dual A again. And look, and it'll trim different. And then I can take a zoom window, and I can zoom into the data. This is the same type of graph that's on the scopes that they use. So this whole way to manipulate the graph is really, really useful. So like I said, you can zoom out to full, and I want to look at this over here, just this time period. I can zoom in on that data. Say I don't want to read that data, I can take that data, put the wrong one there. I can shut that off and only read this stuff. And if I want to blow that up, take my zoom window, and now I made it bigger. I want to make it bigger. There it is. So being able to do that is great. Then I can even pull in the acceleration data, the volumetric efficiency data from the test. I can look at that a little clearer and manipulate it. The other thing that's really nice, if I go to multi-tool over here, I can look at 8 channels. I like using 4 because it makes the graph bigger. I can also select what I'm reading, and not only what's coming from the scanner, but if my scope is hooked up to this, my ESCAN Elite, or even my Limited, I can read 4 to 8 channels off of my oscilloscope. So I can look at a data signal from like a PID here, let's say for, oxygen sensor voltage, and I can also be physically connected to it. And if there's a difference of what my scope is reading versus what the actual scan tool is reading, now I got a problem. So what's right, my scope or the scan tool? So nice way to tell if the scope is misinterpreting the data. The scan tool is misinterpreting the data there. Really, really useful. So everything, as you can see, it's a little more than a scan tool. It's it is a tool. A scan tool is a tool, but this is more of a, I don't even know how to, it's in its own class. It's not just to hook up and read codes. You can really get deep, view the data, and a test tool for, I don't even, like I said, if I want a scan tool, I pick out my Varus. This will help you troubleshoot diagnostic problems. Just even right here, this is something they have on the scope too. But it'll just say channel 1 through channel 8. And what's nice on the scope is it'll have a red box, and if it can detect if you're probed into a circuit. So when you're back probing, sometimes you're like, am I actually connected to the circuit? It actually biases the voltage. It's very good at small bias voltage. So when you back probe something, it goes from red and the box clears. So it's a great feature on the scope, and that's something every tech knows. Like, you're back probing something, then you run the test, and now you're wondering, wait, was I really making a good connection? And only mechanics and techs would know that problem we face. So the president, Bernie, being a really good technician, he's built that feature into the scope, and that's why these programs really work well. Another thing is, like on the DTCs, you can read it continuously. I don't know if I already said this, but this is really nice. This has already helped me. I can run my scope, let's say, whatever it is, let's say throttle position is acting up. I run in my throttle position sensor, and as soon as I get a code, we trip a code, this will stop my scope also. So instead of you doing a test drive, and it's a half an hour test drive, and the code comes up, I don't have to scrub through all the data. I have a mark. The scope actually stops right there. So when you go back to the shop now, you can look at that point instead of scrubbing through all the data. You can see what led up to that code tripping. Trying to think if I'm missing anything else. This goes back to older cars, where some older cars didn't send out the O2 data. So this will request it on like old vehicles. You can see right here, this is for non-canned vehicles only. Canned vehicles results are reported with mode 6 data. So so this stuff will do older cars too. Like I said, they're using generic OBD. So good tool. It's the ESCAN. Yeah, it's the ESCAN by Automotive Test Solutions. Highly recommend this, and highly recommend their scopes. Even if you can get the older ESCAN Limiteds, you can find those cheap sometimes on the internet. Great scope. You can get the 4-channel. You can get the 4-channel E-scope Elite, and I don't know what they call they're both Elites, but there's an 8 and a 4-channel. 4-channel's great too. So I'll do another video on the scope, how useful that is. And then I'm going to do another video on 8 scope. That's another great tool. So, that's it. And like I said, this meter thing right here, this is great just for a straight up view. You just want to read battery voltage or whatever. You got 4 meters here. Let's look at the map. Bam, it goes up. And you can set the, I think you can, I'll give you specs. I actually didn't know the Chrysler 300 had, 340 horsepower. Didn't even know that. You can put the barometric pressure at the shop location, and that helps. You want to do that because that's going to help with all the tests that you run with the sharpshooter and stuff. So that's the tool. Jesus, half an hour video on this, but it's worth it. It's definitely a tool worth getting. And that's it. Adios.